parable of the farmer and the rancher will help illustrate how trade and specialization based on comparative advantage can make everyone better off. In this section, we'll be using production possibility frontiers to graphically show the process. We'll be calculating opportunity costs, terms of trade, and gains from trade to basically show how the farmer and rancher can both be made better off by effectively specializing based on comparative advantage. So the assumptions of the model. What do we need to assume in order to show the gains from trade and specialization making everyone better off? Well, the first assumption is that we have two actors. And in this case, we have the farmer and the rancher. Each of these actors produces two goods. And this is a process just to simplify the story. So the two goods are meat and potatoes. Okay. The third assumption that we make is the optimization assumption. And remember that the optimization assumption is that both parties try to maximize utility in this case. So they're both striving to maximize utility or their own happiness. In this case, what that would mean is the ability to consume both meat and potatoes. The fourth assumption is that there is 8 hours in a given day. So their only input is the time they put into the production of the good, and they will have 8 hours each day to produce. Okay, for step one, we need to look at the inputs needed for the production of meat and potatoes. So we're basically trying to see how long it takes the farmer and the rancher to produce 1 ounce of meat and 1 ounce of potatoes. Okay, so for the rancher, we have that meat production. In order to produce 1 ounce of meat, it takes the rancher 20 minutes to produce 1 ounce. For the farmer, it takes 60 minutes to produce 1 ounce. For potatoes, it takes the farmer 15 minutes to produce per ounce, and the rancher, it takes 10 minutes to produce per ounce. Okay, so if we go back to thinking about the concept of absolute advantage, okay, remember our absolute advantage is based on inputs. So whichever entity, country, party, farmer or rancher uses fewer inputs, in this case our only input is time, then that individual will have an absolute advantage. If we have a look at our chart here, we could see that our data is obviously organized in terms of inputs, right? And in this case, inputs is the amount of time. So in this case, we can see in order to produce 1 ounce of meat, if we compare the farmer and the rancher, right, we see that the rancher uses less time, and therefore the rancher has an absolute advantage in meat production. If we think about the potatoes, again, if we compare that the farmer needs 15 minutes to produce 1 ounce and the rancher needs 10 minutes, right? The rancher is using fewer resources or fewer amount of minutes in order to produce the potatoes, and therefore has an absolute advantage. So in this case, in terms of absolute advantage, the rancher has an absolute advantage in the production of both meat and potatoes. Okay. So if you recall from the previous section, we do not base trade on absolute advantage, because if that was the case, large countries like the United States would produce every good by themselves and be better off for it. We know, based on the findings of David Ricardo, that that wasn't necessarily the foundation of trade. We now know that we have to also look at comparative advantage. So before we look at the comparative advantage, what we'll need to do is convert this table of inputs, Right, so we need to go from this table of inputs into creating a table of outputs, and that will be our next step. So let's convert our inputs from the previous slide into total outputs for the entire day. So if we think about the case of the farmer, we saw that in the other slide that it takes the farmer 60 minutes to produce an ounce of meat. Now, in 60 minutes or in 1 hour, that means that he can produce 1 ounce of meat. So if we take that and multiply it by the 8 hours he has in the day, if he spends all day producing meat, then he can produce 8 ounces of meat per day. So for the farmer, he can produce a total of 8 ounces of meat in any given day, but if he spends all his time producing meat. Now, if he spends all his time producing potatoes, we know again from the previous slide that it takes him 15 minutes to produce 1 ounce of potatoes. We know that there's 4 15-minute periods within a given 60-minute period. So 4 ounces per hour times the 8 hours per day, he can produce 32 ounces of potatoes. Using the same logic, we can use the information for the rancher. We know it took him 20 minutes in order to produce an ounce of meat. And we know there's 3 20-minute periods within an hour. Times 8, we know that the rancher can produce ounces of meat. It took the rancher 10 minutes to produce an ounce of potatoes. So he can do 6 ounces per hour times 8 hours a day and end up with 48 ounces of potatoes. So 24 ounces of meat is the maximum amount of meat that the rancher can produce in any given day if he spends all his time producing meat. And if he spends all day producing potatoes, he'll end up with 48 ounces of potatoes. Notice that this confirms what we found before in terms of the absolute advantage, that in total production, if the rancher wants to spend all day producing meat, he produces a lot more than the farmer does. And if he spends the whole day producing potatoes, he also produces more than the farmer does as well. Now, the next thing we're going to do in the next slide is we're going to take this information and convert it into the PPF graphic. Step 3, drawing the PPFs for our farmer and rancher. So what you'll notice here is just like a little XY axis where I put potatoes on the X axis and meat on the Y axis. It doesn't in fact matter which axis you use, but what's key is that for both participants you label the same good X axis and the same good Y axis. All right, so looking at our chart we created in the previous step, our total amounts produced in one day, we're going to recreate that and put that into our PPF graphs. So for the farmer, we know that the farmer, if he spends all his time producing meat, he will produce 8 ounces of meat. So we'll say this will be our 8 ounces of meat the farmer produces. And if he spends all his time producing potatoes, he will end up with 32 ounces of potatoes. So here we make the assumption that you have a constant opportunity cost, primarily because we don't have much other information in order to suggest anything otherwise. And the reason for that is because our input or our resource, that is time, is basically the opportunity cost is constant, as you don't lose time if you work more on one task versus the other. So this isn't like an input such as, I don't know, capital equipment or something like that. So let's connect the dots here. And here's our first PPF for the farmer. Now for the rancher, if he spends all day producing meat, he gets 24 ounces of meat. And if he spends all his day producing potatoes, he ends up with 48 ounces of potatoes. You can clearly see very quickly that the PPF for the rancher is a lot more further out from the origin than is the PPF for the farmer, which means effectively that the rancher can consume more goods. The next thing here we're going to label is their current levels of consumption. So for simplicity, we're just going to assume that the farmer and the rancher just spent half the day producing meat and half the day producing potatoes. Okay, so what does that mean in terms of their total production any given day? Well, it's effectively the midpoint of our PPF. So the farmer ends up with 4 ounces of potatoes to consume at the end of the day, and the rancher ends up with 16 ounces of potatoes to consume at the end of the day. So this point here, we'll call it A, and that will be a consumption and production point. So without specialization, this or trade, this will be the production and consumption point for the farmer. So he gets 4 ounces of meat and 16 ounces of potatoes. For our rancher, again, same scenario, spends half the day producing meat and half the day producing potatoes, in which case he ends up with 12 ounces of meat and 24 ounces of potatoes in any given day. Once again, we'll call this point A, which is a production and consumption point for our rancher. Clearly we can see, right, that the rancher gets more goods than the farmer. The next chart I want to show you guys is what is current world production, so we could start off with a starting point to compare it to at the very end once we begin to trade. So let's have a look. We're going to look at total world production, and our world currently comprises of a farmer and a rancher. And we'll say without trade. Another term for the word without trade is autarky. Okay, this literally means without, so autarky, trade. Okay, so world without trade. All right, so we're going to look to see the production currently of meat, potatoes, farmer's contribution, rancher contribution, and then total. Okay, so we know that the farmer spends half the day producing meat, and in that time is able to produce 4 ounces of meat and is able to produce 16 ounces of potatoes. When the rancher spends half the day on meat production, he gets 12 ounces of meat and 24 ounces of potatoes. So the current world production without any type of trade is going to have 16 ounces of meat and 40 ounces of potatoes. So our goal is to basically improve world production where at least one of the commodities has increased in terms of production and consumption for our two parties. Step 4, opportunity cost and comparative advantage. So now we're going to use the opportunity cost in order to figure out who has a comparative advantage in the production of the specific goods. So the first thing we're going to do is we're going to take our total production in terms of output. And what we're going to do is we're going to calculate the opportunity costs. So what we're going to look for is the opportunity cost of 1 ounce of meat, and that will be given to us in terms of potatoes. So the opportunity cost of any good is basically how many units of the other good you give up in order to produce 1 ounce of meat. So again, the opportunity cost of meat would be how many ounces of potatoes must be given up in order to produce 1 ounce of meat. So for the farmer, in order for the farmer to produce 1 ounce of meat, we would calculate the opportunity cost by taking 32 divided by 8, and we find that he would have to give up 4 ounces of potatoes. In order to produce 1 ounce of potatoes, right, we do 8 ounces divided by 32, and we find that in order to produce an ounce of potatoes, he would have to give up 1/4 of an ounce of meat. Now for the rancher, in order to produce 1 ounce of meat, he would give up 48 out of 24, or 2 ounces of potatoes. And in order to produce 1 ounce of potatoes, he would give up 24 over 48, or half an ounce of meat. So in order to see who has a comparative advantage in meat and who has a comparative advantage in potatoes, we compare the opportunity costs. So let's start with meat. So in order to produce an ounce of meat, the farmer will have to give up 4 ounces of potatoes. But the rancher has only to give up 2 ounces of potatoes, and therefore the opportunity cost for the rancher in meat production is lower. So the rancher will have a comparative advantage in meat production. Now, in terms of potato production, again, if we compare the farmer, in order to produce 1 ounce of potatoes, the farmer gives up 1/4 of an ounce of meat. And in order to produce 1 ounce of potatoes, the rancher gives up 1/2 an ounce of meat. In this case, we can see that 1/4 is obviously less than 1/2, and therefore the farmer has a comparative advantage. Now you notice that unlike before, absolute advantage can be had by one individual in the production of both goods. But when we're looking at comparative advantage, we could see that anytime we look at the comparative advantage between individuals or countries, etc., one country will have a comparative advantage in the production of one good, and another would have the comparative advantage in the production of the other good. So again, we find that the rancher has comparative advantage in meat, which is expected given the definitions of their jobs, and the farmer has a comparative advantage in potato production. So now, what does that mean in terms of producing goods and services? Well, as a starting point, we can try to figure out to see who specializes in what. And we know that based on the theory of comparative advantage, that the individual that has a comparative advantage in the good should specialize in the production of the good. So the next step, what we're going to be looking at, is to figure out whether or not it's possible in this case to have total specialization. So step 5, is total specialization possible? In some cases it will be, and in some cases it won't be. But to do so, we think of this situation. So we think of our farmer, and if the farmer had a comparative advantage in potatoes, we know that the farmer can spend their whole day producing potatoes, in which case he would yield 32 ounces of potatoes based on our previous work. The rancher would completely specialize in meat production, and he would produce the 24 ounces of meat, right? Because he'd be spending his whole day producing meat. So the idea is they would totally specialize in the production of the good in which they have a comparative advantage, and then they would trade on some agreed upon terms of trade or on some agreed upon price, which we will later see relates very strongly to the opportunity cost. But let's first test to see if this total specialization is possible in this world. So the first thing we would need to do is basically look to see what was world production before trade. So here's the chart we reproduced before, right, where we said that if each party just produces in order to consume without trade, the total world production of potatoes is meat is 16 ounces, and the total production of potatoes is 40 ounces. So now let's take that and compare it to our possibilities when we have total specialization, where each produces based on their comparative advantage. So with total specialization, what ends up happening is this result that we have up here. So we would end up with a total of, so here with total specialization, okay, so this would be effectively, we could say this is a point of autarky, so no trade. And with total specialization, the outputs would look like this. We'd end up with 24 ounces of meat, okay, but we'd end up with 32 ounces of potatoes. So what happened is if these individuals completely specialize, yes, we will get an increase in meat production of 8 ounces of meat. So you'd get an additional 8 ounces. However, if we went to total specialization, we'd actually lose 8 ounces of potatoes. Therefore, in this case, if we do get a reduction in one of the commodities, that would mean that total specialization is in fact not possible. So what does that mean? Well, it means that we're going to have to shift around some of our resources. Step 6. Since we could not totally specialize, then we're going to have to find our new production points. Okay, and we're going to find these based on our comparative advantage. So one thing we know for sure, since the farmer has such a high opportunity cost of producing meat, and his entire day producing potatoes is yielding less than the socially optimal level, right? He should just spend all his day producing potatoes. So farmer is totally specialized in producing potatoes, so is spending all day on potatoes, which yields, as we have already calculated, 32 ounces of potatoes. Now, what does that mean for the rancher? So the rancher will have to divide his time between meat production and potato production, since he has an absolute advantage in both of the question is, what is the optimal division of time? So we're going to start off just simply by looking at, reducing 1 hour in meat production and giving that 1 hour to potato production, and see if that's sufficient. If not, then we'll go on to more movements. For simplicity, we'll only do 1 hour changes for this problem. So first, let's think about the rancher spending 7 hours on meat and 1 hour on potatoes. Okay, we know that his potential output, since we've seen it already in our previous slides. So what happens if that was the case? If the rancher spends 7 hours on meat production, he will yield 21 ounces of meat. We know this because it takes him 20 minutes in order to produce an ounce of meat. So in any given hour, he can produce 3 ounces times the 7 hours per day. He can get 21 ounces of meat. In the 1 hour that he produces potatoes, he will yield a total of 6 ounces of potatoes. Now, let's see if that will be enough. So what would that mean for total world production? That would mean that, of course, we know that the farmer contributes ounces of potatoes plus the 6 ounces of potatoes from the rancher, and now we're at a grand total of 38 ounces of potatoes, which is actually fewer than our world optimal of 40, or our original before trade total. So this will actually not be sufficient, and we don't even need to look at the meat production, where we can clearly see 21 ounces is above the initial total of 16 ounces of meat that was produced. All right, so let's change the production. Let's say now that a rancher will spend 6 hours on meat and 2 hours on the potatoes. Okay, so what does that yield? Well, the 6 hours on meat will yield a total of 18 ounces of meat, and with 2 hours on potatoes, he will yield 12 ounces of potatoes. So in a given day, the rancher can produce 18 ounces of meat and 12 ounces of potatoes if he splits his time with 6 hours on meat production and 2 hours on potato production. Well, what does that do to our total world production? So our total world production as a result would be meat. We'd have 18 ounces produced by our rancher, right, which is greater than the 16 ounces we had initially, if you go back to one of our previous slides. In potato production, we had the 32 ounces produced by the farmer plus the 12 ounces by the rancher, and we end up at a grand total of 44 ounces of potatoes, which of course is above the 40 ounces that we had before. Back to our PPF, and let's display our new points of production. So here on this chart, we'll have a look at where the farmer is now currently producing. The farmer now spends all his day producing potatoes for a grand total of 32 potatoes. We'll call this point point B. And point B is purely a point of production, because remember, the farmer is not going to be satisfied only consuming potatoes. He needs some of the meat from the rancher in order to be fully satisfied. Now, for the rancher, remember, he spends 7 hours on meat and ends up with 18 ounces of meat. And he ends up producing 12 ounces of potatoes. So once again, we'll label this point B, and once again, this is a full point of production only, not production and consumption. Okay, so before we go on, we need to figure out the price of these goods. So here on the next slide, we're going to be looking at the terms of trade. And in order to assess the terms of trade, we will be asking the farmer and rancher a series of questions. Now, this is the long way to the answer. There is a shorter way that we will learn later using simply the opportunity cost. Step 7, the terms of trade. So now we'll be using these production possibility frontiers that we generated in a previous step to basically answer a few set of questions in order to determine the price that the goods will be traded at. So we go through a series of questions. Now let's start with looking at things from the perspective of the farmer. So question 1, what is the maximum of number of potatoes would the farmer be willing to give up in exchange for meat? So what we do is we start to look at our current production value for the farmer. So we see that the farmer is producing 32 ounces of potatoes. So the maximum amount he'd be willing to give up would be an amount that would leave him at least as well off as he was before. Before, he used to be able to consume 16 ounces. So the maximum number of potatoes he'd be willing to give up would be 16 ounces of potatoes. Now, what's the minimum amount of meat that he'd be willing to accept? Well, currently he is producing 0 ounces, And before trade, he was producing 4. So the minimum amount of meat he'd be willing to accept, right, in order to allow for trade to occur would be 4 ounces of meat. Now let's look at the rancher. So for the rancher, again, we'll look at the rancher's production possibility frontier. Okay, so for the rancher, what is the maximum number of ounces of meat would the rancher be willing to give up in order to accept, in order to get potatoes? So initially, the rancher was able to consume 12 ounces of meat. And produce 12 ounces of meat. Currently, he's able to produce 18 ounces of meat. So basically, to leave him off as well as he was before, the maximum number of units of meat that he'd be willing to give up would be 6 ounces of meat to the farmer. In exchange, the minimum amount of potatoes he'd be willing to accept, well, again, currently he's producing 12. He used to be able to consume 24. So the minimum to leave him as well off as he was before would be 12 ounces of potatoes. So where would the price of trade be? Would it be anywhere between those values? So for example, you can come up with a trade agreement where, say, 4 ounces of meat is traded for, say, 13 ounces of potatoes. You can do one that says 4 ounces of meat is traded for 14 ounces of potatoes. We can do 5 ounces of meat being traded for 16 ounces of potatoes, 5 ounces of meat being traded for 15 ounces of potatoes, etc. So any numbers that we can pick out somewhere between these endpoints, right, between the min and max acceptance, right, would be a possibility for our terms of trade. So for simplicity, I'm going to pick an easy value, and that's going to be, to set up the terms of trade, we're going to be trading 5 ounces of meat for 15 ounces of potatoes. Okay? So this is going to be our terms of trade. Now, once we get to our terms of trade, that actually will change the opportunity cost for both of our producers. Let's see what that means. So going back to our original table of our opportunity costs, we found that for the farmer to produce an ounce of meat, he'd give up 4 ounces of potatoes. For the rancher to produce an ounce of meat, he would give up 2 ounces of potatoes, which meant that the rancher had the comparative advantage in meat production. When we go to potatoes, in order to produce 1 ounce of potatoes, the farmer gave up 1/4 of an ounce of meat. And for the rancher to produce potatoes, he gave up 1/2 an ounce of meat. So in this case, of course, the farmer had the comparative advantage. Now, based on our terms of trade that we established, we said 5 ounces of meat will trade for 15 ounces of potatoes. So what is our new opportunity costs? Well, the opportunity cost of 1 ounce of meat, remember, is going to be potatoes over meat, which is 3 ounces of potatoes. Right? Now notice something really interesting here is that that value is in fact right in between our original opportunity costs. So meat cost 4 ounces of potatoes for the farmer and 2 ounces of potatoes for the rancher. Based on our new opportunity cost, meat costs 3 ounces of potatoes. Now what about opportunity cost of 1 ounce of potatoes? Okay, so of course we know that it's of course the inverse. So we do 5 over 15, which is 1/3 of an ounce of meat. So once again, if we go to our chart here, or table, right, we notice that that new opportunity cost is in fact right in between our initial opportunity costs. And we can see that for the rancher, it is now cheaper to consume potatoes, right? The farmer is getting a little bit extra meat, and so on. So what we've seen is once you establish the terms of trade, they will be between the opportunity costs. So terms of trade could be set anywhere in between the two opportunity costs. So just to state that here, terms of trade are in the middle of the original opportunity costs for each party. So we could have in fact just looked at this chart and found exactly the midpoint of each of the opportunity costs and set the price rather than going through the questioning process. Back to our PPF. Now let's label our original production points and consumption points, our new production points, and then finally, what are our new consumption points after trade has occurred? So what we see here currently is just our autarky levels of consumption and production. So point A tells us currently how many units the farmer produces and the rancher produces and consumes at the same time. Now, once we started to specialize based on comparative advantage, the potato farmer produced only potatoes. So point B here is basically just a production point. Now, for the rancher, he spent 6 hours a day producing meat and ended up with 18 ounces of meat, and he produced 12 ounces of potatoes. This would be his current production point. Now to get our consumption points, remember what happens. The farmer gives 15 ounces of potatoes to the rancher, right? This is what we established in our terms of trade. And the rancher, in exchange, gives 5 ounces of meat to the farmer. Okay, so let's look at those new points of now, not production, but consumption. So initially, the farmer had 32 ounces of potatoes. He gave up 15, so now he ends up with 17. And he received 5 ounces of potatoes, so now he has 5. His new consumption point, we'll call it point C, right? This is a pure consumption point. Now notice this is outside the production possibility frontier, which means without changes in technology, without changes in inputs and so on, he's able to consume outside his production possibility frontier. Now let's have a look at the rancher. Now for the rancher, what we notice is that he currently has 18 ounces of meat. He gives up 5 to the farmer. So now he has 13 ounces left for himself. The rancher is currently producing 12 ounces of potatoes, and he receives 15 from the farmer. And so 12 plus 15, we now have 27 ounces of potatoes for our rancher. So this becomes point C and or the consumption point for the rancher. And once again, notice that it is outside the production possibility frontier without the expansion of any kind of resources or inputs or technological change. Using our production possibility frontier from the previous slide, we can compare the world without trade, the world with trade, and we can finally measure our gains from trade. So what we found is initially, before trade, the farmer had 4 ounces of meat and 16 ounces of potatoes. The rancher had 12 ounces of meat and 24 ounces of potatoes. With trade, production for the farmer was 0 units of meat and 32 ounces of potatoes. For the rancher, we had 18 ounces of meat and 12 ounces of potatoes. The terms of trade were 5 ounces of meat for 15 ounces of potatoes. So the farmer got plus 5 ounces of meat and gave up 15 ounces of potatoes. The rancher gave up 5 ounces of meat and gained 15 ounces of potatoes. So our new consumption point for the farmer was 5 ounces of meat, 17 ounces of potatoes. For the rancher, 13 ounces of meat and 27 ounces of potatoes. So what were our overall gains? Well, let's compare point A with point C. Okay, so in this case, what happened with meat consumption? Well, initially the farmer was consuming 4 units, now is 5. So we got plus 1 ounce of meat for the farmer. He was consuming 16 ounces of potatoes before, now he has 17, so plus another ounce of potatoes. For the rancher, he gained 1 ounce of meat, and in terms of potatoes, he gained 3 ounces of potatoes. So overall in this world, we had an extra 2 units of meat created and an extra 4 units of potatoes created in this world setting, which basically left both of our parties better off. Is this the only possible outcome in terms of the trade agreement? Absolutely not. Right? We may have situations where the trade agreement benefits more one party than the other. This terms of trade that we set in this problem was the most equal distribution. We can of course set a price something like 4 ounces of meat for 16 ounces of potatoes, in which case the farmer basically gets no gains from trade, and the rancher is the one that basically will get all of the units of goods that were created because of specialization. But what we are still looking for is that trade must leave everyone as well off as they were before at the minimal. Okay, so trade must leave you at minimum as well off as you were before. So this concludes the parable of the farmer and the rancher. And the most important takeaway from this is by simply specializing in the good in which each individual had a comparative advantage, they were able to both consume more goods simply through trade without having to invest in any new infrastructure, without having to invest in new technology, increasing resources, increasing workforce, and so on. So this is just purely gains created from the fact that each party specializes.